your first thought might be, well, okay, I got to give it a place to go. So you're going along the sides and removing that snow so that when you shed the snow from the top, it has somewhere to go. What you're actually doing in that scenario, you are potentially going to add to the risk of failure, because that side is holding, the snow is holding the sides in, so the top can't come down because the sides don't go out. I have had a long-time customer in Thunder Bay that actually never removed the snow from around his buildings for that simple reason. He just figured, you're getting a pile of snow around the edges, that's just holding everything so the top can't come down. That was his philosophy, and that's not exactly what I recommend, but it worked for him for many years. The best device for removing snow is something T-shaped like this. Now this particular thing, because it's just a small demonstration model, it's not actually finished. The top side should have some old carpet or other padding on it, and this is also something that you should have made in advance before there is a problem, because if you're scrambling, you know, when you've got all this snow that has to be gotten rid of, then you could be faced with a situation like what I did once, where I just got a big chunk of PVC pipe, put one of my old boots on it, and started banging at the structure that way. Having something like this is a lot more effective and a lot safer. The pole on this should be long enough so that you can shake it like this rather than reaching overhead. It's a whole lot more strenuous when you're doing it overhead than if you're doing it from a power position. It is important to, when you're bumping the snow, is to not do all of one side and then do the other side. Bump it here, bump it here, bump it here, bump it back and forth like that, going down the line. Also, when there is a lot of snow, do the center of the structure first before you go along the sides with the snowblower and start removing it. Even though when you start to remove it, you won't be able to do it totally, but even getting, you know, say 10 feet of the middle area clear is going to increase the odds of a successful clear. When it is especially important when you're bumping ice off of a building to start at the top, because even if you have a thin layer of ice that really in itself isn't a problem, but you just want to make sure that, you know, just in case we have that scenario that I described a few minutes ago, what happens is if you bump the ice here and just go along like that, and then you bump it up higher, the chunks of ice could slide off and fall back, and you're still going to wind up with a slashed cover. If you have a building that is severely stressed and you're looking at this and you're thinking there is no way that this is going to be saved, your best bet still, as harsh as it might sound, is to slash the cover from the outside. It is just a matter of putting a knife on a pole and slashing it. It's a lot better to sacrifice the cover and save the building than wind up having to clean up the whole mess. Any of you that know me or have seen one of my presentations before will recognize this little graphic. There is a distinct similarity between the profile of a greenhouse and the shape of an airplane wing. The big thing is you want the opposite result. So as you're sitting comfortably in your airplane seat looking out the window at the wing, and you're feeling quite comfortable that this big hunk of metal is going to get off the ground and bring you safely to your destination, and then you get back home and you're looking out the window as you're listening to a really nasty weather forecast, are you equally as confident that that greenhouse is still going to be standing there in the morning as it was as the previous evening? If you've ever looked closely at an airplane wing, you'll notice that there is a lot of moving parts. The purpose of these moving parts is to create more surface area, because for an airplane wing, more surface area is more lift. A number of years ago, I started aircraft school to get my pilot's license, and even though life kind of got in the way and I never got to finish that process, it did give me a much better understanding of aerodynamics and how then I could apply that to the manufacturing process. As the wing extends, you're getting a lot more area, lot longer distance over the top than you are underneath. So the air that travels over the wing has to travel significantly faster than what goes underneath. When air travels faster, it gets thinner. When air gets thinner, it has a vacuum. That's how you get lift. And it is important to understand that concept in how it applies to a structure. So how does changing the profile affect aerodynamics? I have a couple of illustrations, a couple of examples to illustrate. A few years ago, I had a customer that put up a 30 by 60 building on 12-inch steel I-beams that he had inherited from somewhere. At 50 pounds per lineal foot, this was like 3,000 pounds per side that he had this building attached to. And in his mind, that shouldn't go anywhere. Anytime anybody says that's not going anywhere, I get a little nervous and I just kind of ratchet it up a little bit tighter. So in this particular situation, he had a particularly nasty storm that came from the side. So you got this building standing like this with the wind coming across. The air is thinner on this side, creates a vacuum. It literally sucked this side of the building with a 3,000 pound I-beam on the bottom. It sucked it out until the building was now 38 feet wide. The top had come down 4 feet, so now because there was that reduced distance over the top, the lift was reduced and it stopped moving. So it was sitting there fully intact as a 38 foot wide, now 11 feet high. He did not install cross ties in that particular situation because they were deemed as they're going to get in the way of what I'm doing. So he didn't put cross ties in. That would have saved his situation, because basically if that can't go out, his problem wouldn't have happened. Had another customer, and this one, he did install cross ties, but he had a 27 foot wide, 108 feet long, that he mounted on really big barn beams. These barn beams were about this wide. They were about like this. He'd gotten them from somewhere. Obviously, if he had to buy them, he wouldn't have bought them. Now, he put this building behind a really big glass greenhouse. This glass greenhouse was much, much bigger than this greenhouse. Now, so you got the big greenhouse, you got the smaller greenhouse. Over here, you've got all sorts of trees, and then in front and behind, there were another greenhouse. So this whole courtyard was extremely protected. And he just had that thing sitting there. Now, the winds came across in one storm, came over that greenhouse, the big greenhouse, at about 100 kilometers an hour. This whole structure moved sideways 60 feet before the leading edge caught something, and basically it just kind of folded over. Because at that point there was enough momentum that the backside just kept on going. In both of these situations, we were able to salvage most of it. The first one, the ridge was gone, so I had to supply him with a new ridge, but all the rest of the parts were good, and he bought cross ties when he reassembled. For the second one, again, the arches were all still fine, all the parts were fine. He bought a new ridge and he had to buy new purlins or new cross ties. So definitely it could have been a whole lot worse. So now coming back to the building that's pictured over here, when you go from 30 to 34 feet wide, like we mentioned previously about the extra snow load that you get, but because you're bringing the top down, you're actually decreasing the wind load. It's a decrease of about 50%, so you're getting a decrease of around 30% in your wind load. The cross ties that were installed in this thing, they basically tie the two sides together. So not only does it keep it from spreading, but when the wind comes from the one side, the two sides are tied together. So as this one's being pressured, this one's actually holding it, so it stabilizes the building quite a bit. In this particular application, because the structure then was mounted on the block, so the 2 feet that he lost by spreading it, he gained back, so that was equal. In most cases, if you spread the building and you're getting that reduced wind load, that would mean that you're getting more snow sitting on the building as well. Not only is it flatter, but because there's less wind, it doesn't blow off. So when you're not counteracting the two, you need to keep those things in consideration. The last thing to remember is wind is a potential 365-day-a-year potential problem. Snow is a wintertime problem that can be alleviated through heating. So how close is too close? Once again, that depends. The obvious thing is that you need to have the structures far enough apart so that if you are faced with a situation where you have to remove the snow, there's room to get it in between. The thing you have to remember though is, how did the snow get there? If the wind, the prevailing wind is in line with the structure, the snow on there is going to be a lot more balanced and you're going to be removing snow a lot less often. If the wind is coming from the side all the time, you're going to get a lot more snow that is all on one side, and you're going to get a buildup here and no snow over here. In that scenario, you're going to be removing the snow much more frequently because of this sideways push. Another thing to keep in mind is how the water is going to be shed, because as I mentioned previously, how the structures shed water and you're getting that area magnified with the amount of moisture that's there. In these particular things, if you get a combination of wider buildings and smaller spots in between, you better take significant steps on improving the drainage in that area. Otherwise, you're not going to have much holding power for the anchors in that area. Another thing that becomes magnified when you have the wind coming across the buildings, the way that I've talked about, you're getting that vacuum on the back side. Well, when you have multiple buildings, it does seem to magnify each one progressively, and you have even more pressure on the last one than you do on the first one. And I had an opportunity once years ago where I had 8 structures in a row to replace with plastic, and the wind was coming from the side, and my thinking was the same as most other people. Well, if we can get the first one done, then we've got the shelter so that the next one is out of the wind and will become easier. And I was really amazed at how each structure, as we went down the line, it actually became more challenging. The leading edge was easy to attach, but then the plastic is coming like this, and even when we're standing in that area, there's absolutely no wind there. We can't reach the plastic. The plastic is just flapping up there because it's being sucked right up. Is this building at risk without a cover? That seems to be one of the hardest things that I can get through to people, is for them to realize how much combined wind load that there is on a building when you consider the total number of square inches of surface area exposed to the wind when you have no cover on it. In this particular unit, I did the math and discovered that the total surface of all of the arches that are there was 745 square feet. Meanwhile, that when the building was finished and a fully closed end was only 540 square feet. So that's why we stress over and over again the importance of tying the building. As soon as you get that first section up, you put a rope on there and you tie it off both ways to something very secure. Because not only is it easier to have the building standing plumb, but as you're doing more parts, you're collectively getting potentially more wind on it, so you're stabilizing it. What was really frustrating about this particular situation was the answer that I got from the customer when I said, where was the rope attached? Because you can see there is a rope there. So I asked him, well, where was the rope attached to? And he said, well, I saw in your instructions the importance of tying off the building, so when we had that up, I put the rope on there. My brother thought this whole concept was silly because we were building up against a big barn. The prevailing wind was coming from the other area, so the barn was sheltering this whole construction process. So the rope wasn't tied to anything. So in this particular situation, basically what happened was the wind coming over, creating that vacuum, the new building was like just sucked away from the other barn. Because of the way this one fell, there was a lot more repair than just the ridge. Obviously the ridge was shot, but like all of the spacer bars that were attached to it already, they were all twisted. The brackets that fastened to it, they were twisted. So the repair on that one was quite a bit more substantial. Before I wrap this up, I do just want to come back to this slide for a minute and talk about windbreaks. The only true windbreak is a row of trees. Many people have said to me in the past, like, I'm putting my building behind this building or that building, so it's going to be protected. What happens in that scenario is when you've got a big building here and you're putting your greenhouse over here, now when the wind comes like this, straight on like this, now you've got a vacuum. If the wind starts coming a little bit more from this way, you're getting swirling like this. Then as the wind starts to change to the other direction, it goes to, again, a point of vacuum, or it goes a little bit farther. Now you're getting swirling the other way. So not only is your building not protected at all, but you're actually making the condition worse because it's constantly being, in very rapid succession, being jostled from one position to the other. It doesn't take much of the wind just in a minor way changing direction, and it really magnifies the stresses on the building. As I mentioned, a windbreak, a tree line is the only true windbreak, but there are ways, correct ways, and incorrect ways. The spacing of these trees is actually an extremely effective for windbreak, but the problem is of how close it is to this structure. It is really too close to be effective. It's sort of the same idea as if you were putting a snow fence like 3-4 feet beside your driveway. It's going to block all that snow, but it's blocking the snow in the wrong spot. I'd like to thank you for your attention and for your interest. And I hope that with the things that I have covered, you are now you're developing a bit of a checklist so that you can go home and make sure that your investment is safe. Are there any questions?